Hi, welcome to my channel Robotics for Juniors. We will make another project in robotics in this video. We will use a button and LED both in the circuit and connect it to Raspberry Pi. In the previous video, we learned about the basics of a button, its internal connections, and how to use it in the circuit on a breadboard. We also learned about the GPIO library GPIO 0 to be used in Python to use a button. In today's video, we will do the Python programming in Thonny Python. It is an IDE of Python. That means it is a software for writing and running Python programs and is very easy for beginners. We can run the program from this software itself instead of running it from the terminal or shell like we did in the previous videos. The purpose in our project will be that when the button will be pressed, the LED glows, then it sleeps for 5 seconds and then switches off. So let's look at the circuit diagram. In the circuit, we connect the button in same way as earlier. One of the pin of button is connected to ground at board pin 6 and the other pin to board pin 3 where it gives input to the Raspberry Pi whenever the button is pressed. In GPIO pin diagram, these are the two pins used for button. The LED is a polar hardware component, that is, connections are positive and negative terminal specific. The positive of LED is connected to the resistance. The other end of resistance is connected to board pin 11, that is GPIO 17. The negative end of LED is connected to ground, board pin number 6. In GPIO pin diagram, the pin used for LED is this. The ground is common for LED and the button, that is pin number 6. Let's put the components together. Keep the circuit diagram with you for making the connections. Start by putting the button across the gap on the breadboard like this. The basics of why the button is connected like this can be found in my previous video of the project, How to Connect a Button with Raspberry Pi. With any colored jumper wire, connect one pin of the button to board pin number 3. The other pin of the button on the same side of the gap has to be connected to ground. So we connect it to pin number 6 of Raspberry Pi with black jumper wire. Now this whole line of sockets has a ground connection. We take a female to female jumper wire and connect this line to this bus stripe. Now this whole vertical line has ground connection. The negative terminal of LED, that is the smaller leg, has to be connected to ground. Let's connect it like this with smaller leg in the bus stripe. Now connecting resistance of 440 ohms to the positive leg of LED. We have taken a combination of two resistances of 220 ohms each. The other end of the resistance goes to board pin number 11. This completes our connections of hardware components. Now switch the Raspberry Pi on. As we will be using Thonny Python, the software to write and run Python programs, we go to Raspberry menu icon, select Programming, and then Thonny Python. So this interface opens. This is the button to create a new file for our program. This is the main area where we type our Python program. We start by importing GPIO 0 library. This is a GPIO library which makes our code a lot simpler by providing different modules. Instead of importing the whole library, we import only the modules which we need. So we write From GPIO 0, import button LED. Since we want to put some time delay between switching the LED on and then off, we import the sleep module from the time library. From time, import sleep. Now declare the variables for LED and button. LED equals LED 17, button equals button 2. Here we use the pin numbers for Broadcom values, which are 2 for button and 17 for LED. Board pin numbers are used for hardware connections and Broadcom pin numbers are used for software programming. Now putting a print statement that we need to press the button. So print, press the button. Next, button dot wait for press. The program is now waiting for the button to be pressed. The statements after this will execute when the button is pressed. Print button is pressed. And then switching on the LED. LED dot on. Now let there be a time delay of 5 seconds. Sleep 5. Print LED switching off. Switching the LED off. LED dot off. At end, we can print goodbye. Print goodbye. This gives the information that our program has ended. So this completes our program. Now we save the program by this button at some location. Now the program is saved. We run it from this button. And this area is a console where the output is displayed. So we run the program. The program is waiting for the button to be pressed. We press the button. The print statements are printed on the console and the LED switches on. It glows for 5 seconds and then switches off. We run it again. So that's it for today's project. Next video will make changes in this program so that every time we press the button, LED toggles. That is, it switches its state. If it's off, it will become on, and if it is already on, then it will switch off. Let me know your feedback by writing comments or liking the video. Subscribe to my channel, Robotics for Juniors, for upcoming projects and tutorials.